We're going to take a look at the Pythagorean identity. When it comes to trig, again, we're dealing with right triangles. Now, the Pythagorean identity should remind you of the Pythagorean theorem. Now, the Pythagorean theorem states when I square the two short sides and add them together, I am going to get the square of the hypotenuse. So the Pythagorean theorem is a squared plus b squared equals c squared. Now the Pythagorean identity deals with trig. So what we're going to do here is we are going to use the Pythagorean theorem here to figure out the values of sine and cosine here. So here we have a right triangle, and it says we have some angle theta where the sine is 1/2. So here's the right angle. Sine, if we remember our acronym, SOHCAHTOA. Sine is your opposite side over your hypotenuse. So if sine is 1/2, that means the side across is 1 and your hypotenuse is 2. So our unknown side is x. So we have to figure out the value of cosine. Now the Pythagorean theorem states our square of the short sides, so 1 and x, so 1 squared plus x squared is going to give me my hypotenuse squared, which in this case is 2 squared. So 1 squared is 1, x squared we can't do anything with just yet, so it remains x squared equals, in this case, 4. So to get x by itself, what we have to do here is subtract 1 from both sides. So we end up with x squared equals 3. And last but not least, we have to take the square root of both sides. So we end up with x equals the square root of 3. So if I want to find cosine, cosine is your adjacent side over your hypotenuse. So adjacent side in this case is x, which we just found to be square root of 3. So root 3 over our hypotenuse, 2. And we can do that with every right triangle that we given. Just like in number 2, we have a right triangle where sine of theta is 7/9. What's the value of tangent theta? And we have to draw a diagram to illustrate it. So again, we have a right triangle, some angle theta, where sine is 7/9. So opposite over hypotenuse, 7 and 9. And we're going to use the Pythagorean theorem to figure out our unknown side here, x. So again, it's a squared plus b squared gives me c squared. So our short side, we have 7 squared plus our unknown short side gives me 9 squared. So 7 squared turns out to be 49. B squared we can't do anything with just yet, and that's 81. And what we're going to do now is we are going to subtract 49 from both sides. And we get b squared is 32. And again, we need the value of b, not b squared. So we're going to take the square root of both sides. That's going to cancel out the square root and the square, leaving me with b equals square root of 32. And if I want to find the value of tangent, now that we know all our sides, so x is now square root of 32, tangent is opposite over adjacent, 7 over our new short side here, square root of 32. And again, it's just applying the Pythagorean theorem to our right triangles. So same deal here, using the idea, how can we solve for x here? So here we have a right triangle, some angle that's approximately 53 degrees. And because we know 2 out of 3 sides, we can use the Pythagorean theorem to figure it out. So a squared plus b squared gives me c squared. So our short side is 0.8 squared. Plus our unknown side, x or b squared, is going to give me our hypotenuse, 1 squared. 0.8 squared is going to give me 0.64. Plus b squared is going to give me 1. And again, if you don't know what 0.8 squared is, we just get out the calculator, and we do 0.8 squared. Gives me 0.64. We're going to subtract it from 1. So we got to get b squared by itself. So we're going to subtract 64. It's going to cancel these guys out, leaving me with b squared. And then 1 minus 0.64 gives me 0.36. And to figure out the length of it, we have to take the square root from both sides. So square root and square cancel out, leaves me with b, or in this case x, equals, and then I can take the square root of 0.36. And we get 0.6. So again, use the Pythagorean theorem, pretty straightforward. Any right triangle, we can use that theorem in order to figure out any one of the missing sides. We also could have used tangent, sine of 53, tangent of 53 equals 0.8 over x, solve for x that way. So we had a few different options, but in this case, we use the Pythagorean theorem. So let's talk about this identity. Now, an identity is something that always happens to work given a valid proof. So we figured out in the previous problem the measures of this triangle. We were given 0.8, hypotenuse of 1, and we figured out that our short side was 0.6. So how do we figure out where the sine and the cosine come into play? Well, if we remember our acronym, SOHCAHTOA, sine of our angle, any angle, is equal to the opposite over the hypotenuse. So if I take a look at this, sine of theta here is going to be 0.8 over 1. And again, it's a fraction, which denotes division. Anything divided by itself is 0.8. So notice this side here is 0.8. Hence, we can say this short side is also sine of theta. Same with this side over here, cosine of theta. Cosine is adjacent over hypotenuse, which we found to be 0.6. And then the hypotenuse is 1. Again, we divide 0.6 divided by 1 is just going to give me 0.6. So because it's the same value, we can say this side is also cosine. So sine theta, cosine theta. Now if we think about the Pythagorean theorem, a squared plus b squared gives me c squared. I can apply it here as well. So square the two short sides. So short side is sine. So we can square sine of theta, and I can square cosine of theta, and my hypotenuse being 1, I can square. Now, when I square sine of theta, it ends up being, that exponent ends up being on sine. So we end up with sine squared theta plus cosine squared theta equals 1. When I square it. So there's the identity we are going to be using. Sine squared theta plus cosine squared theta equals 1. And last but not least, we can also say tangent is equal to sine over cosine. So again, we just found up above if we have sine squared, if we have sides like this, sine and cosine. So here's our angle theta. Here are two short sides. The one across from theta is going to be sine of theta, and then the adjacent side is going to be cosine theta. And again, tangent being opposite over adjacent. Opposite is sine of theta, and the adjacent side is going to be cosine theta. So we can use that to our advantage as well, if need be. So here we're going to use the Pythagorean identity to figure out the value of cosine. So just like up above in number 1, we used the Pythagorean theorem to figure it out. This time we're going to use the Pythagorean identity. we still have a right triangle, some angle theta, and we are told sine is 1/2. So again, sine theta, cosine theta, and then hypotenuse will be 1. So identity states sine squared theta plus cosine squared theta gives me 1. So sine of theta being 1 means I have 1/2 squared plus cosine squared is going to give me 1. When I square 1/2, I get 0.25, which as a fraction is 1/4, so we have 1/4 plus cosine squared theta gives me 1. I'm going to subtract 1/4 to get just cosine by itself, cosine squared theta gives me, and then I can do 1 minus our answer, 0.75, which as a fraction is 3/4. So now that we have just cosine squared theta being 3/4, what I need to do now is take the square root, just like in the Pythagorean theorem, we take the square root. It will cancel off the square root and the square, so leaving us with just cosine theta. And when I take the square root of a fraction, I take the square root of both numbers. So square root of 3 is just square root of 3. Square root of 4, we end up getting 2. So cosine theta ends up being √3/2, which is what we found to be our answer number 1. Now number 4, we use the same identity, this time using sine of theta equaling 7/9. So again, same formula, same identity. Sine squared plus cosine squared is going to give me 1. Well, sine is now 7/9, which I am squaring, plus cosine squared is going to give me 1. Just like before in the previous problem where I take the square root of both numbers of a fraction, if I'm squaring a fraction, I have to square both numbers. So 7 squared gives me 49 over 9 squared, which is 81, plus cosine squared gives me 1. We'll subtract 49 over 81 from both sides. So we get cosine squared. So 1 minus, in fraction form, 49 over 81. And we get this nice little decimal, and we'll put it back into a fraction. 32 over 81. So 32 over 81. So now that we have just cosine squared, we have to take the square root of both sides. So that way there, the square root and the square will cancel out. So we have just cosine. And again, just like before, I have to take the square root of both numbers. Square root of 32 is just square root of 32. It's not a nice number that we can do. And then square root of 81 ends up being 9. So cosine theta being square root of 32 over 9. Here we have cosine being 4/5. We need to find both sine and tangent. So to find tangent, we need to know what sine of theta is. So remember previous little tidbit we learned, tangent is equal to sine over cosine. So I need to figure out what sine is first. So we're going to use the identity we've been using to figure out the value of sine. So sine squared plus cosine squared gives me 1. We don't know what sine is, so we're just going to keep it as sine squared theta. And then cosine being 4/5, we're going to square it, gives me 1. So sine squared theta, when I square 4/5, I get 16 over 25. gives me 1. We'll subtract 16/25. So we have sine squared theta equals, and then 1 minus 16/25. And I get 0.36, which as a fraction is 9/25. We'll take the square root of both sides, and we get sine of theta. Square root of 9 is 3. Square root of 25 is 5. So sine of theta is 3/5. Now we get to figure out what tangent is. And we learned that tangent of theta is equal to sine over cosine. So in this case, sine of theta we said was 3/5. And we are over cosine, which was given to us, is 4/5. So what we'll do is we'll just divide the fraction by a fraction. So in the calculator, we have 3/5 divided by 4/5. And we'll get 0.75, which will turn back into a fraction, is 3/4. The other way we could do it, and remember when we have a fraction divided by a fraction, we do keep, change, flip. So we could do 3/5 times 5/4. And the 5's will cancel out, leaving us with 3/4. Same thing for number 6. If we have sine of theta equaling 44/125, we got to find cosine and tangent. So sine, again, find tangent, we need to know cosine. So we'll use the identity first in order to figure out cosine. So we have sine squared theta plus cosine squared theta gives me 1. We have 44/125 squared plus cosine squared gives me 1. And what we'll do is we'll square 44/125. We get this nice little fraction, and because our problem is in a fraction, we'll try to put it back into a fraction, which it won't. So in this case, we'll just do 44 squared. We get 1936 over, and then we'll do 125 squared. Gives us 15625 plus cosine squared gives me 1. And then we have to subtract this nice big fraction from both sides. So we end up with just cosine squared equals, and then we'll do 1 minus our fraction, 1936 over 15625. And then hopefully we can turn it back into a fraction, which is not going to let us. So let's do, again, 1 as a fraction, it'd be 15,625 over 15,625. So 15,625 minus 1936 gives me 13689 over 15625. And we'll take the square root of both sides to get cosine. So square root of our answer is 117. And then I got to take the square root of 15625, which should be 125. Going backwards. 125 squared gave me 15,625. So if I go backwards, take the square root, I'll get 125. So sine of theta is 44/125, and cosine theta is going to be 117/125. So now that we know what cosine is, I can apply it to tangent. And again, tangent is equal to sine over cosine. Sine we were given is 44 over 125. And we're dividing it by cosine, which is 117 over 125. So what we can do now is we can either plug it in the calculator, top fraction divided by bottom fraction, or we can keep change flip. So 44 over 125 times 125 over 117. So because 125 is on the bottom and the top, they're going to cancel out, leaving us with just 44 over 117, which if we can reduce it, we'll plug it in, 44 divided by 117. It'll give us a decimal. If it can be reduced, which it can't, we'll leave it at 44 over 117. So there is the value of tangent. And again, this can be used for any one of our problems. So again, finding sine, we can use the Pythagorean identity. Same with this 8th problem that we are given. We can use the Pythagorean identity to figure out our missing sides. And it is very, very similar to the Pythagorean theorem. So as long as you remember the Pythagorean theorem, we can remember the Pythagorean identity.